And there's notes that we took. If this is working, it hasn't been working the greatest, but today it's working. I hope it continues to work. There might be 15 minutes of notes that you can get on a Google site, and I'll show you where it's at here after we do this, just as a reference. But you can get the notes off of that site, as well as our discussion. Right? So, when we met last, we talked about we don't have an atmosphere. That's why I was asking you guys, what have we been studying? Okay, atmosphere. The atmosphere is a filter. Filters out a lot of bad radiation, electromagnetic radiation. So we don't have as intense amounts. If we did, we'd have very hot days, very cold nights. We'd have high amounts of UV radiation. That causes cancer. That would cause a lot of things that would not be living anymore because they could not take that intense UV radiation. No gases you'd have for life support. And you'd have zero pressure. And we know what would happen if you'd have zero pressure. Okay? Alright? So those are things. I'm going to go through this real quick. Because if you don't have this down, you can go ahead, again, get on the website. You can get them down real quick. Alright? Where do we get it from? I think you have this down too, right? That, we pretty much get all our energy directly or indirectly, and a lot of it's indirectly, through the sun, because the sun is the primary source of energy that the earth has. And most of it goes to vegetation, which produces oxygen that we need to have to survive, plus the food. Alright? So, that takes place because of nuclear fusion. Fusion is taking two atoms and putting them together. Fusing. Think of fusing something together, putting something together, that's what's happening. Okay? So it's nuclear fusion. If you think about it, our sun is about as good a distance apart from the earth as you can get. So the earth is the third rock, they say third rock from the sun, and it is a really good distance. If we would be farther away, it'd be a lot cooler during the day and night, and if we were closer, it'd be a lot warmer during the day and the night as well. So we're in a really good spot when we take a look at the angle the Earth has at about 23 degrees, and about our seasons and that, it works out pretty good. Any questions about nuclear fusion? It's just, we need to put it in there to kind of see how the energy is given off. For what? What's that? Yeah, you can see it. Yeah, okay. All right. So, the next part I want to take a look at is that about half the radiation we get from the sun gives off is infrared. And about half of it is visible light. Visible light doesn't cause any problems. Visible light has a wavelength structure that, the frequency at which it's at, it's not going to cause us any problems. It gives us all the different colors. It's really good that we have all the colors. I mean, if everything was black and white, you guys ever watch black and white old movies?
Yeah.
Yeah. They're kind of cool, nostalgic and that, but if you saw everything in black and white, that would be, you go outside and it just look gloomy every day, and you can have all the neat little combinations of different colors. So that visible light, red, orange, yellow, green, blue, violet. Okay, we'll get to that. UV light's 9%, so it doesn't produce much of the higher frequency range, but ultraviolet would be 9%. The infrared is a shorter or longer wavelength and a lower frequency. And at that frequency, so we know waves have a frequency. A frequency means so many waves passing a point in a second. And if the waves are longer, there will be less waves that pass a point in a second. At that frequency, it causes molecules to transition from slower vibration if they're a solid to moving faster if they're a gas. Okay? So basically, it will heat up the atmosphere and the land because it will produce the wavelength that is ideal for allowing molecules to move faster. So if you look through infrared goggles or something that detects infrared, you see in the movies where they'd have that on there and they can see through buildings or and they can see figures, like through a tent, for example, outside a tent, and otherwise it couldn't see motion or movement in there. It's based upon heat. Okay, it's based upon heat waves that it's detecting. Okay, UV light is a high frequency light. It actually causes chemicals to separate, break apart. And if you do that in some lower life organisms like bacteria and that, it'll kill the bacteria. So if you get high enough UV light in some of the life forms that are single cell or simpler form, it will kill those type of organisms. If we have cells in our body, it will kill cells on our skin if we get too much UV light. Okay? So those are the things that are caused by UV light, sunburn. It's used as a way to allow medical tools, okay, equipment to be sterilized. So it's a way of sterilizing so that if they use it, it doesn't infect whatever it's being used to work on. And so that's UV light. Okay. And then of course the last one is the visible spectrum. I remember it as ROYGBIV. R stands for what? Red, orange, yellow, green, blue, indigo, kind of a bluish color, and then violet. Okay? Red has the lowest frequency, okay, longest wavelength. And violet has the highest frequency, shortest wavelength. So if I ask you on a test, and I ask you which of the following colors have the lowest frequency and longest wavelength, and red's your choice, and then you have blue and violet and orange and yellow, red would be your answer. If I ask you on a test coming up, which of the following has a high frequency color? You can think of ultraviolet is beyond violet, but color violet would be your choice. Violet's your choice, it's on the end, highest frequency. R is the lowest frequency. Okay? Any questions on visible light? Right there, you can see the visible spectrum up there. It goes the same way. Red, orange, yellow, green, blue, indigo, white. Okay. We only have a couple more slides. We're going to look at each specific radiation and what in the atmosphere it affects. Okay? So we know the atmosphere acts like a filter. It actually absorbs energy as well. And so we're going to look at the effects of the atmosphere interacting with these waves. Once you go ahead and write that down, wavelength and frequency are inversely related. You guys know what inversely means, right? I hope by now you do. Inversely means that they change in opposite directions. So here was data from the spring. The wavelength went down, so the frequency went up. So as we got shorter and shorter waves, those waves moved up and down a lot faster, more frequent. And this is a type of graph that you would get if you got an inverse relationship. Okay? So this graph is inverse. These numbers in a data table are inversely related. You guys also did a lab for me where you plotted altitude versus pressure. And this is the graph that you put together and handed in. So this is also inversely related. Okay? Anytime you get this type of graph, like a ramp, looks like a ramp, skateboard ramp, kind of, that's an inverse relationship. Okay? So I could ask you that in a question. You know, if the frequency is increased, what happens to wavelength? You say it goes down. It goes the opposite way. Before the waves from the sun get to the surface, most of it is absorbed by CO2 and water vapor in the atmosphere. So before the infrared radiation that's produced by the sun gets to the surface, a lot of it is going to be absorbed. Now, so when I say absorbed, what do you think is happening to the motion of CO2 and water vapor? Speeding up. So these are speeding up. They're absorbing energy and they're going to move faster. So it's going to heat up the atmosphere. Okay? It's going to heat up the atmosphere. And that's going to happen when you have IR. So the very small percentage of this type of wave actually gets to the surface. When it hits the surface, it heats up the land. UV light, thank goodness, most of it's absorbed by the ozone layer. Now, probably 15, 20 years ago, there was something that they stated was given off by refrigerators and air conditioners that had to be changed. You guys know what can be given off if they start leaking. They said it affected the ozone layer. So does anybody know what was given off by those type of equipment? Oh. Fluorochlorocarbons. You ever heard of fluorochlorocarbons?
I was going to guess carbon.
What's that?
I was going to guess carbon.
Carbons. Well, it has carbon in it. We had an automotive store, my folks had an automotive store, and they used to sell canisters of refrigerant that you could go and put, if you got low, your air conditioner's blowing out cold air, you could go and get, we sold a lot of them. And what you could get a kit in which to hook up and then put more refrigerant in your air conditioner. Can you do that now?
In what?
In your vehicle, can you do that?
Yeah, you just
Go to the store and do that? What's that?
try to find your valve and put a nose to it.
But can you go buy that at the?
Yeah.
I didn't know you could do that.
$5.
What's that?
Freon. Yeah.
Freon.
Yeah.
I didn't know you could do that.
Yeah.
I thought you had to go somewhere to have it
All
done.
you do is twist it on there and put the thing on there.
Right. I didn't know you could do that. I thought they did away with that because if you got a leak and it's putting it out in the air, then what it does is it interacts with ozone and it depletes that ozone, they say ozone layer. So I didn't, unless they have a different type of refrigerant that's not Freon. I don't know. But it has to get in the stratosphere before that happens. So the chlorofluorocarbons that you're giving off here has to go up 20 kilometers before it would get to the ozone layer. But does that happen very much? Probably. I wouldn't think so. I think it's going to stay down here. I don't think it's going to reach up there. But I could be wrong. All right? In invisible light, most of it reaches the surface. So IR and UV, very little of that actually makes it to the surface. Visible light, most of it because of its frequency. So our atmosphere is saying, hey, we'll let visible light through, but we're not going to let UV light through, and we're not going to let a whole lot of IR through. And that's good for us. Okay? If it was like, we'll let a lot of UV light, but not much visible light, that wouldn't be good. Right? Last thing that you need to write down. Is this something that could affect your generation much more than myself? And it is, they're going away from gases that will cause the possibility of what's called a greenhouse effect, which means a warming of the atmosphere. Why do I say that? Because they're going to do away with most of the fossil fuels if, if the right people get in charge. They're going to say, we don't want any more fossil fuels. We want everything ran by wind, solar, hydro, electric. Your bills will
Shoot up.
get higher and higher and higher. Okay? If that happens. So, there's individuals that really like green energy, and they don't want anything to do with coal or petroleum. And coal and petroleum right now are very cheap in which to produce electricity, where the others are just starting up and they're a lot more expensive. So, what happens is the energy given off the surface in the water will be absorbed by gas molecules in the air. You guys know what gas molecules they are that affect the greenhouse effect. There's 3 of them.
Nitrogen.
What's that?
Nitrogen.
Nitrogen. There's a nitrogen compound that is. Yep.
Is that it?
No. We talked about one. In fact, you guys did the experiment where you produced some. CO2 and
Carbon dioxide.
water. And methane. Methane is natural gas. So these 3 things in the atmosphere will absorb infrared and will keep the heat in. Any questions? Not right now. That's a little bit early. At the 40 you can go. Okay?
Cross out.